Morning, folks. Welcome to the Podman Community Meeting. This is Tuesday, February 6, 2024 already. Today, or for this meeting, we meet on the first Tuesday of even-numbered months. Topics are driven from suggestions either from here today or from people sending them off to me. Always happy to take just, topics from folks, especially ones that are doing demos kind of stuff. And it doesn't have to be just Podman. It can be Buildo, Scopio, or any other related container projects. I'll be taking the meeting notes in the HackMD. And I'm not sure if that's the right MD in the presentation, but I'll put it up in the chat in a moment. Feel free to correct me or add to it, especially if you have links, if you're doing the meeting, if you're doing a demo of some sort that would be useful for folks. Go ahead and do that. And today we have John Masters here giving us a little demo on how he uses Podman at his home. Urvashi Mahani will be doing a Podman Build Farm demo. Brent Bodie will be doing Apple Hypervisor demo. Matt will be giving us an update on Podman 5.0, and then we'll have some time, I think, for topics from the general field. So all that, I'm going to stop sharing, and I'm going to hand it over to John.
All right. Well, I wasn't planning to do a live demo, but I'm going to talk through what I do with Podman for home automation. Hi everyone, I'm John Masters. I previously actually worked at Red Hat. These days I work elsewhere, but still very, very fond of the Red Hat family, and particularly a diehard Fedora user kind of forever, right? So yeah, Tom and I have been talking a little bit about the benefits of using Podman in home automation, right? Which I wanted to speak a little bit about. So my sort of home automation journey, I think, is very similar to a lot of other people. You start sort of seeing all these smart assistants out there, and pretty quickly you go down this rabbit hole of, well, I could fill my house with lots of Wi-Fi devices, and run lots of proprietary software and proprietary services, and rely on talking to cloud services to turn on my light switch. So I push the light switch and wait for some endpoint somewhere else to tell me I can turn the light on. Or you can sort of take your destiny into your own hands, right, and run everything yourself. And of course, that's the path that I took as a diehard Fedora user. So then you go down this path of running your own on-prem home automation. And in particular, there's sort of two directions that the world has gone until now, and that is using either Zigbee or Z-Wave devices. This is basically a relatively low-range self-forming mesh network that you build by getting devices and putting them into your home. And now there's new standards like Matter coming along as well. But basically what I ended up doing was, around this house that we purchased a couple of years ago, replacing every light switch, anything that moved pretty much, with a Zigbee endpoint. And so what that means is you have a nice API, you can interrogate your light switch and ask it, are you on, are you off, what settings do you have, all this kind of thing. And when you're trying to deploy something, even in that home setting, when you're trying to deploy something that you want to just work, that's when you go from, kind of your weekend hobby hacking to, I have people, my wife, I have other people in my house who expect things to just keep working. And you can't sort of say, well, the light switch doesn't work today. So what I tried to do is make the infrastructure a little bit more robust. And that's where containerization comes in. That's where the use of Podman comes in, right? So what I'm running is a variety of services. So for example, I have a Zigbee as a physical protocol, right? So that's a wireless mesh network that's got in this house probably 200 endpoints, something like that, right? I've gone a little bit overboard, and I've got a container running. A Zigbee daemon that passes through hardware, right? So that was one of my first sort of, fun experiences, with doing hardware pass-through with Podman. But passing through a USB device that terminates these the sort of on-the-wire radio protocol. And then I'm running a variety of other containers that connect to this. So I have an MQTT broker. In a different container, I run Home Assistant, which is a popular home automation framework. That's in another container. And then, building the sort of, that robust story. So, every time I want to experiment, right? The thing I found particularly useful with Podman is every time I want to experiment with updating these different components and running test containers, I'm not having to, tear down what works, right? That's what I particularly like with this model of deployment. That I can try out the latest version of Home Assistant, right, and not interfere with what I'm running in production. And then I have a lot of the auto start stuff enabled as well. So if I get a power failure, everything restarts and comes back up. I haven't done a lot with monitoring yet. Everything is using SE Linux with enforcement. I see Dan is here, right? So that took a little bit of effort, particularly with hardware pass-through. And then the thing I've done most recently is I've decided to go full on crazy with adding some cameras outside my house. There were some thefts in the neighborhood, right? So I added cameras outside, and to monitor those, I'm using something called Frigate, which is yet another fully open source project. And in that case, what I'm trying to do is offload image recognition. So it'll do full motion tracking of, well, everything that moves outside the house, right? I've got these cameras that are called pan tilt zoom cameras that can actually move and physically track things. But I'll talk about that. But in order to deploy that, in order to deploy Frigate, that's using physical hardware that's doing inference, machine learning inference. And so again, there you're doing hardware pass through, which has really been the biggest challenge that I've had in deploying any of the services that I run. And it was actually slightly harder there because I decided I wanted to run VMs with containers inside those VMs and pass through the hardware twice. That is still a pretty challenging thing to do. But in general, doing the hardware pass through has been, kind of okay. I would say that's been my biggest challenge with Podman. Is that the other challenge that I think I've had is simply, anytime you go online, right, everyone's still talking in terms of, Docker containers, right? The muscle memory, the sort of, collective opinions that people have on the internet are all formed around these other container runtimes. And so sometimes you just have to spend a few seconds just figuring out, what's different here, or, if you care about security, right, and you want to use things like SE Linux, how does that map where not everybody else is really, thinking in that same way. But the challenges have been very, very minor. In general, I found Podman to be, a very good way to deploy home automation in a way that scales, in a way that lets me rebuild containers and have reproducibility, right? So if something happens, I need to update things. Again, generally stuff doesn't break, and that's quite important. So that's sort of my perspective, Tom, on what I'm doing with Podman, and I'd be happy to answer a question or two if there's time.
Yeah, not a question so much, but if you could send me a couple of links to some of the things that you're talking about as far as the physical devices and stuff, that'd be great. I'll add them to the notes for folks.
I will do.
And this also sounds like a great blog topic from you at some point in time, if you ever want to put it all together. Yeah,
sure. Yeah, in fact, what I'll do is I'll send you a couple of links, and I'll send you a couple of pictures of like the dashboards and the interfaces, and people can take a look at what it all looks like when it's running.
Great.
Are you doing this with rootless or rootful?
So this is rootless, but it's again, you've got challenges there.
The devices would be real challenging with that, I would figure.
Yeah.
Yeah, and are you using Quadlets to start services?
Not right now.
Yeah.
Yeah, not right now. I should do. I know it's. Yeah, I know, Dan.
Yeah.
Not yet.
That was very cool.
Yeah, I think it's.
But great. Yeah, rootless, dealing with the security and device permissions and all kinds of things. That's where the fun and games comes in.
And you have your voice assistants working with this as well?
I do, yeah. So so there's Home Assistant. Actually, there's a company that funds the Home Assistant project, and Casada is, I think, Casita. I forget the exact name of the company, but basically, you can pay a monthly subscription. So it's a subscription service that funds their developers, and as a sort of benefit of that, the $5 or $10 monthly fee, they run an endpoint that Home Assistant can connect to, and it will integrate with the different cloud assistants. So all of them work in this house, right? Like not just the Google ones, but everything else works here too. And so the nice thing there, though, is again, it's kind of optional, right? Like everything still works without the internet running. Everything still works without any of these cloud services. It's just you can also, you know, talk to your thermostat and say, turn this thing on, right? And it will do it. Yeah. Well, turn the light on or whatever, you know, it's all very integrated that way. Yeah.
Nice.
Now we had one question on the chat. I was wondering if you tried Matter, I think is how you pronounce it.
Yeah, Matter is kind of the latest and greatest protocol that's just sort of hit the wire. And it basically you know, is sort of things like IPv6 and, you know, nice, clean, modern standards for plugging things together, and it's all just going to work. And allegedly, and a lot of these devices are coming to market now with this sort of plug and play. So it's great in the future, but Matter is still sort of just landing now, right? So yeah, I think there'll be a migration over time. But one of the challenges is also that, you know, when you deploy something in a house, you know, you want something that's going to be still, you want something that's going to work the next 10 years, right? So the quick answer to why did I deploy, you know, with Zigbee, in my case, Zigbee 3.0, which is encrypted as opposed to the previous versions, is because it's a well-established protocol. It's a self-forming mesh. So the different light switches in the house that have power, some of them are routers automatically. They will route things together. Again, it's going to keep working for years and years to come. And that's quite important. Even though in 10 years' time, it's going to sound really old school to be using Zigbee. But that's how the world is, right? You want something that has a long-term story. And again, with the Podman piece, everything is reproducible. And so if any of these projects go away, I can do that self-support in 10 years, which is also important.
We had another question who's asking, can you give a one minute replies to why you want Zigbee instead of Z-Wave?
Yeah, so Z-Wave, again, stop me if I sound like someone who's very enthusiastic about open source all the way, right? So Z-Wave is a slightly more proprietary, has slightly more proprietary heritage. It started out as a proprietary thing and then kind of got opened up. But if you look at the players there's one or two players because that's kind of the history, whereas Zigbee has always been more of an open standard. And so, you know, frankly, that was one of the reasons why I went with Zigbee. I'd also heard of Zigbee more. But Zigbee 3.0, I like the encryption story there. I like the fact that you have different vendors that you can plug together, and it more or less works, right? There are a couple of vendors that are incompatible, which is annoying. And the other thing I found with a lot of these mesh networks that you get today is, you know, by default, what you'll find is that anything that turns up just gets to join your network, right? And so I've obviously turned that feature off. So, you know, I noticed one weekend I noticed that my mesh had become weirdly shaped, and it was because a neighbor of mine purchased one of these IKEA smart light switches, and it decided to join my house. And I thought, I can try to explain to my neighbor how any of this works, or I can kick his device off and lock it down, which is what I did. So sorry to my neighbor, but yeah.
Great. Don't have any other questions in chat. Does anybody else have one for John before we move on?
Well, I'll share a couple of links, and you can follow me on Twitter, John Masters. Ask me any questions, and thanks for letting me speak.
It was very interesting. Thanks for coming by, John. I appreciate it a bunch. Right. So next up, we have Urvashi Mahani talking about Build Farm demos.
Yep. Let me just share my screen. Okay. All right. Hello, everyone. My name is Urvashi, and I'm an engineer on the Container Tools team. So today I'm going to talk about a new command we added to Podman called Podman Farm. So one of the ways you can do multi-architecture builds with Podman and Builder is using emulation via the QEMU user static package. But then with emulation, we take a hit on performance. The builds are like much slower when you're doing it with emulation. So we kind of thought about what can we do to try and make these builds happen on like native on machines that are of the native architectures, and without you having to like access those machines manually to run the builds yourself. So we kind of came up with this concept of Podman Farm, where with Podman currently, if you have a machine that's able to run the Podman socket, you can connect to it via the Unix SSH command. So we have something called Podman system connection. So you can connect to the Unix socket running there over SSH. So given that we already had this ability with Podman, we decided to extend that such that you can create a group of connections and call them farms. So these are essentially machines that you could then, send out your builds to with one command from one machine, basically. So here's the help command of what the farm looks like. You can create farms, you can remove farms, you can, then the important one is farm build, which is what you use to send out the builds to your farm machines. So over here in the demo, I have 3 farms, and I'm using 2 virtual machines because I don't have access to like physical machines. So the reason it's recorded because the virtual machine that is running the ARM architecture is actually emulated, so it's extremely slow. So I recorded it so we don't have to sit through that. So I have 2 machines. My Fedora 37 machine is a regular AMD 64, and then I have the Fedora 38 machine, which is an ARM 64 machine here. And with Podman System Connection LS, you can see that I have set up those system connections, and they are pointing to my Podman socket running on those 2 machines. And then a farm basically is a group of 0 to as many machines as you want in your farm. So the first command I'm going to run. Okay, so I have a Docker file here, which is just a basic Docker file that prints out the architecture and the date. So this is just a help command of what the farm build looks like. Basically, you have all the options and flags that you would have with the regular Podman build command. So essentially, you have the same functionality, basically. So the first command here I'm running is I'm setting local to false because when you are building on a farm, local is set to true. What this means is that the images will be built on all your machines on the farm as well as on your local machine. So for this case, I just want to build on the 2 machines in my F1 farm, which are the F37 and F38 ARM. And as you can see here, I gave it a full image name. Basically, I gave it a registry and repo because once your images are built on the farm nodes, we directly push the images to the registry. Then we create a manifest list with a digest of those images and then push that manifest list as well to the registry. So after the build is successful, after all the builds are successful on all the machines, we push the images to the registry. So as you can see here in the end, it says we save the list to Humanani 8, my image 1. So when I do Podman images here on my local machine, I'll just have the manifest list, my image 1, and not any of the built images or any of the images that were built on the farm nodes. So here when we inspected the manifest list, we can see we have 2 images of different architectures available, the AMD 64 and ARM 64 as expected based on the farm machines. So the next command here I'm running, I'm leaving local equals to true, and I'm using the default farm, which I think was F2, which was the F38 ARM farm that had that machine in it. So as you can see here, it set up the build, my local builder, and it set up the F38 ARM builder. So this time it's going to build an image on my local machine as well as on my farm machine. And one thing I wanted to point out here is that you can see here that it's using cache because I had already previously done a build on that machine in my previous run. So basically how Podman build works, when cache is available, it uses the cache. So now when I do Podman images here, I can see that I have this unnamed, untagged image here. So this was the image that was built during the build process. And I have the manifest list, my image too as well in my container storage. So when we inspect that, we have both AMD64 and ARM64 because my local machine is AMD64. All right, so one thing I wanted to point out was that when you are using farm build, whatever registry that you're pushing to, you have to ensure that your farm nodes also have access to that registry. So if you've set up a local registry, it needs to be exposed for those nodes to be able to access it as well. And all your authentication and credential files live on your local machine. The farm build command is able to grab that authentication and then pass it on to the node so that it's able to connect to the registries and push to the registry then. While I messed up 2 commands here, but basically the next thing I want to show here is that we have a cleanup flag. So let's say that you don't want to leave around any images that were built on your machines. You want to clean them up immediately after the build was successful. When you set the cleanup flag to true, once the images are built and pushed to the registry successfully, we delete those built images. So here I just built on a farm that has the F37 machine. And as you can see, it was only one machine there. So I only have a manifest list with one architecture, which was AMD64. And I just SSH'd into that machine. And when we do Podman images, we see that there's no unnamed, untagged image there. That was cleaned up after the build was successful. So that's essentially what the farm build work does. It's trying to make your multi-architecture builds feel more native and being able to do it with one command from one machine. The machines that you have in your farms, you could emulate different architectures on it, but then because of emulation, it will be slow. So you'll basically be having a performance hit. One more thing I want to show is I pushed these built images to my Quay repo. So I just want to show you what it looks like on Quay. So my image the first one that I built, that had the 2 architectures over inside it. So we can see the latest tag has both the manifest here for AMD64 and ARM64. And then if we look at my image 3, it was just one architecture. When we go here, we see that we only have one architecture here. One more thing that I had done quickly was I have this simple diagram that kind of talks about shows the architecture here. So just a quick recap of what I demoed. You have your local machine that's running Podman. You have your farm set with a bunch of machines that are running the Podman socket that you have connected to with your local machine. The farm build command sends the build data over to those machines. The build is performed. Once the builds are successful, they are pushed to the registry. Once that happens, we get a digest that we send back to the local machine to be able to build the manifest list. The manifest list is created on the local machine and then also pushed to the registry. This is kind of the architecture, and that's it for farm build.
Looks great. I had a couple of questions, but I thought I'd let other people ask if they had anything first.
What is the biggest benefit of using farm versus doing 2 builds?
Sorry, versus doing what?
What is the biggest benefit of doing one Podman farm build command versus doing 2 Podman build commands, one for each connection?
The diagram shows 2 machines in a farm, but you could have multiple machines of different architectures. There are many architectures available, right? So you're not limited to just 2, and you're also not limited to just 3 farms. You can create as many as you want. The idea here is that everything is more automated, and it also creates the manifest list for you, which would not be created if you do 2 separate farm build commands. You'll have to do that manually.
Right. I mean, that is what the shell script is doing today. So that's the benefit, replacing the shell script with a single command.
Yeah.
The goal is to make it so normal humans doing it could feel somewhat comfortable with it. And we want to get it eventually into Podman Desktop so that it would support farm building. So it becomes right from the GUI hand a container file and say, you want to click these 3 arches, and it goes out and figures out how to build those 3 arches.
As far as I know, you will also have to add connections to Podman Desktop, so that could be a prerequisite.
Yeah, but there's certain, if you, I mean, most people that are building multi-arch right now are attempting to do it with you use the static, which is, you know, if you have anything really complex, can really be bad performance, although better on a Mac. So here we're looking at how could we support this in native building, as long as you have VMs and or access to physical machines that are different architectures.
Yeah, I just had a couple, hopefully quick questions. Paul's been answering some of it. What about farm login? Do you have to log in from each machine before you start running this, or is that happening under the covers of the farm?
No, you don't have to log into each machine. Once you have set up the Podman socket on your farm machines and you just do Podman system connection add, that adds the connection logic that's needed, and farm just piggybacks on that. So there's no need to log in anywhere.
Okay, great.
You will have to log into your registries. Like if you want to store credentials, you just do Podman login for the registry, and then the farm build command is able to read your auth file and send that over, basically.
So great, so that saves some steps. And are there any other pre-config steps that people have to worry about?
No, just setting up the socket on your machines and then doing Podman system connection add to connect to that.
If I wanted to do a build where I did one of the arches in emulation mode and then a different one. So say I had, I don't know, S390, but I wanted to do that in farm, but I wanted to do x86 and both on my Mac from a single machine. Can I do that?
From a sorry, what do you mean from a single machine?
So I basically, right now we're identifying the connections based on Arch. Is that correct?
No, we're not based on Arch. So it's once you add a connection, right, and you create the farm, it goes and just builds on all the machines there. Now, if you have a machine in the farm that has the same architecture, like 2 machines, then it will build on the first machine it finds of that architecture.
No, but if I have a machine that can build me an x86 and an ARM, and I have another machine that is S390, and I want to build for all 3 arches, but the one locally has to do it in emulation mode. Is that possible with farm right now?
It is. So right now, I think we're just using the native architecture. There is code in there to determine the emulated architecture, but we haven't tested that part yet. So it's not completely done. But if that's something we want available as well, then we can test that and ensure it's working.
Yeah.
Yeah.
I mean, I guess right now, if you do just a Podman build with 2 arches on a single connection, it will do the emulation. It will attempt to do the emulation anyways.
Yeah.
But good.
Yeah. Any other questions before we move on? Right. Thanks, Vishy. That's great.
Thank you.
Right. You're up with Apple Hypervisor updates or demos. I'm not sure which.
Me either.
Yeah. Okay.
All right. I got a little shindig I can run through here, and I'm going to curse the demo gods by doing it live. So let's start with the end product. I think that tells an interesting story. I will begin sharing here. Can folks see that?
Oh, we can. It just popped up.
This is the end product. So after this, we've been doing a lot of refactoring for Podman 5, and it's pretty intrusive for machine. And this particular PR comes from a teammate of ours, Chris, and essentially it's saying we need our Apple and Mac CI to pass before a new PR can go in. And this is the enforcement that says it must pass, as opposed to, hey, run it, but whatever. And the point being here, this is the big celebratory piece, which is that the refactoring has allowed us to get the machine tests on Mac to pass. So this is the big deal, and one of the big benefits of our refactoring work. So if we go and look at what the refactor actually kind of looks and behaves like, I'll ask that y'all tell me font-wise how I'm doing here.
If you could bump it up at least one, that'd probably be good.
That was one. Better?
Yep, that's better for me anyway.
All right. So let's just clear this off. And I want to show that I'm using code that's at least checked in, or committed rather, and I'm on a detached branch from the upstream machine dev 5. So this is proof of life. And I've already done the make of the binary. So we've got Podman there, and I've got it sort of linked there. So when I call Podman, it's calling the branched one. All right. So for Apple, it always starts, for all of them, it always starts like this. And I have removed the cache and everything that will make it go fast on this one, because I kind of want to talk through it. So the first thing I want to point out for those that haven't been closely watching is you'll see that it's pulling from Quay as opposed to pulling from the Fedora CoreOS distribution server using HTTP. That will be how things work in the future. Right now, as far as exactly what that looks like, we're still kind of ironing that out. This is sort of some trickery going on at present, but you saw that the pull occurred and we went out to Quay to get it. It's not as impressive because right now it's using the version, which is Podman 5, to determine which version to pull. So that doesn't really stick out, but it's pulling, you're doing a comparison on the version and pulling just that. All right, and now I'll further curse myself by not running this with debug. And this will take, I don't know, 30 seconds or so. But meanwhile, I can kind of talk about what's going on. So right now, it's actually used a ton of common code between all the providers, QEMU, Hyper-V, WSL, and Apple. It's using common code to set up almost everything but the final call to actually the machine itself. And then as far as what happens when it's successful, it looks exactly the same at this point. So that was a successful start. I take a peek. It looks like it's running. We can pop into it. Yep, that worked. And we can do some things here. One thing I want to point out is that we do on Apple use VertIFS, so we have a reasonably fast sharing mechanism, and this could be an interesting example here. I want to show some differences. The old configuration file for Apple machines look something like this. And the new looks something like that. It's may be difficult to tell in this sort of environment, but it's considerably smaller. There's a lot less detail in here. Most of it is now abstracted. And this is the key part. This is all common now. There's a bug, Ashley. That's all common, which is nice because now we have a common set of APIs to work with. But this is where it differs, and so this is just the specific stuff you see for Apple. If we were doing QEMU, and the Apple Hypervisor stuff wouldn't be here. It would be strictly QEMU stuff. Worth repeating, but we will be deprecating QEMU for Macs. So Apple Hypervisor will be your only future option. Okay, and just another sort of proof of life here. So this is something I actually run reasonably frequently on my Mac when I'm doing development, is I'm pulling the Golang, the Docker Golang container image, and I am using a mount to mount this repository inside. And so if you look here, we're in the container, we're in the repository, we've got good speed for things, and one of the things we like to do is run something like make validate to see that our code is passing linters. I won't subject everyone to watching this, but because it does take quite a bit of time, but it seems to work quite nicely. So, and of course, everything else is as you would expect. Business as usual, which is what we're hoping for. Before I dump the terminal, any questions?
We had one from Anders earlier. He was asking, why do you need a special image for Apple HV when compared to QEMU? And I cannot say that.
What are you getting at, Anders?
So why is it not the same OS image? Why do you need different OS images for different hypervisors?
There's two reasons. One is that the Apple Hypervisor does not honor the QCOW image.
Right.
And I
So you have
really
to convert
don't.
the format. Yeah. Okay. Yeah.
Yeah, I really don't want to do that on users' machines because I think that adds a level of difficulty. The second thing, however, is that QEMU and Apple implementations differ enough that it makes sense. One example is that we use BSOC communications instead of the native QEMU communications for network. So we need a binary or two that are inside. The rest of the stuff we could largely adapt in the sense that it's all just ignition work, but that's primarily why.
Okay. I was just wondering, it's a different decision.
Yeah, one of the big hurdles, Anders, in all honesty here, was the fact that using a raw image really sort of stinks because it just doesn't out of the box support sparse operations. So when you make 100 gig disk like we do, when that kind of stuff happens, certain operations can take the sparseness away from that disk, and now you're dealing with a massive binary blob.
Yeah, I mean, we are doing it for Lima, but I think So the first attempt was using QEMU image, the program to create the image, but obviously that's not a good idea if you haven't installed QEMU. So I wrote some kind of program to create the image now, but I haven't really used it myself. I think it handles the sparseness, but I can look that up. So it converts the QCOW image into a raw image with the downsides that you are implying to.
Yeah.
You also lose this. So for the QCOW image, you have the actual cow aspect. So you can have a base disk and then your layers on top of that, and that layering is not present in the raw image either. So that means you end up duplicating the OS disk if you have a lot of VMs.
Right. I am contemplating some APFS trickery for CI to make things even faster, which would make copy on writes potentially the only thing being written. But for now, I'm satisfied that it's running.
Have you garnered any kind of performance gains, Apple Hyper-V versus QEMU?
The big thing is the mounts are extraordinarily faster than 9P. That's the big thing.
Have you compared it with FS on QEMU, or
No,
maybe not
in
in
large-
Linux? So, yeah, I'm not sure it works on Mac.
yeah, in large part, my understanding is that the QEMU still doesn't have, like, the one nice thing about VFKit and the way it's designed and we contributed to it is that it holds since it's running the VM technically, it holds the VertaFS daemon, if you will, open and allows that connection to work. My understanding is that's not quite there in QEMU. I may be mistaken, but that's what my reading leads me to believe, and that's why we're still 9P.
It's very manual. QEMU still bundles the old Verta FSD, so you have to deploy the new one, the Rust daemon yourself, and then you can connect to it. But I'm not sure the Mac support is there, so you probably only support Linux and not Darwin.
Yeah, I think Mac support is not there yet. It doesn't run as the shared memory solution is not there, so that's one thing. So some of the people are looking at that how to make VertaFSD work on Mac as a separate process. So I think you have a correct understanding that as of now, the VertaFSD will not work on Mac the way we have implemented it as a separate process in QEMU.
And we as a team and code maintainers would really love if VertaFSD worked on Windows, but nope. So we have kind of this, since we're already have a deviation, we might as well just deal with it. So QEMU still uses 9P. If someone says, hey, we really wished, here's a use case where we use it on Linux and we really need to move it over to VertaFS, we would get that on the list. But the bigger priority for us for Podman 5 was the refactoring to the singular configuration file and sort of making dead ends of our mistakes in the past and getting those out. Dan, you look like you want to ask a question.
No, I don't want to ask a question. I just want to state that QEMU has not been a great experience for us from a stability point of view either. And
On Macs.
On Macs. And the reason for that is mainly that we didn't have control over when the thing is released, and Upstream didn't seem to really care that much about the quality of the releases on a Mac. And so getting to the point where we sort of maintain the VMM outside of, being updated via Brew is going to be hopefully very nice for us from a stability point of view.
Once they get over the shock that we took it away.
You muted.
Other questions? So I think just in general, the message I would send to the community, if they were asking me what gives with this, there are some new things going on. There's a lot of the changes that we couldn't make without breaking API or breaking user experience have been made. But as far as huge technical leaps in Podman 5, that's not a thing. You're more likely to see feature-driven development begin after 5.0 goes out and stabilizes.
Okay, I'm going to wrap this up since we're getting close to the end. We have one more topic yet to go. I'm going to turn it over to Matt talking about Podman 5.0 changes.
Well, this is largely going to be a follow-on from what Brent was already talking about. 5.0 is very much a breaking change release, in that we've had a bunch of stuff over the last 2 years where we haven't been able to fix it because it would be a breaking change to API or it would be a breaking change to the command line output. Small things like better Docker compatibility for Podman stats, Podman inspect, other things like, big deprecations are coming. cgroups v1 is being deprecated. We're not removing the code. We thought we might be, but we're not completely removing it. But cgroups v1 will probably be gone in 6. It's deprecated in 5. The old BoltDB database will still work if you have an existing one, but we're restricting creation of new ones. So this is very much a stability release in the sense that we are addressing a lot of old tech debt, and not a feature release. So don't expect that much in the way of new features. Now, as for schedule, we were just discussing the hour before this, and we're hoping to get a release candidate 1 out either later today or tomorrow, probably tomorrow morning. This is very much going to be an early preview, and I'm expecting a long release candidate phase for this release. A lot of the work we're doing, especially the refactoring that Brent has been doing in Podman Machine, is still very much ongoing, and we're just trying to get test builds out to the community so they can look at what works and what doesn't. I'm expecting Machine is probably going to be on the what doesn't part for a while. But yeah, we are hoping to have a final release out before Fedora 40, and ideally that's going to be sometime in early March, but we don't want to commit too strongly to that right now when there is still a lot of dev work ongoing.
There's a subtlety I'd like to add, Matt, that this morning we talked with Podman desktop folks, and I think one or more of them is here as well, and I think we kind of came to a good conclusion, or at least something I feel comfortable with, which is as we're doing the releases and as Podman 5 releases, if you're extremely dependent on Podman, I think the advice would be to just pause before jumping on top of Podman 5. Give it a little bit of soak time and let us square off some of the yet sharp edges, in particular with machine migration, if we can do anything for folks and things like that. But, this is something we're hoping that we can slow down and brew and don't release immediately as we try to improve the user experience that we expect from ourselves.
Yeah, and hopefully most of this is going to get fixed up in RC. So
yep,
we'll see where we land and how much time we have. But yeah, release candidates are going to start appearing, and we are still very much in development. We're just trying to give people snapshots of where we are.
Matt, I'll bank this off you, and you can drive it home. But also, I would say that we feel very confident in the core Podman code and that base of code in terms of the things we've changed, and that they're good and solidly done.
Yeah, core Podman is very much stable at this point. Most of the instability is going to be coming in the machine side. That's probably why we're going to end up doing so many RCs. So I think even RC1 is going to have a pretty complete preview of what you can expect in Podman 5.0 if you don't expect to be using Podman Machine.
Indeed.
Yeah. I would also like to point out that breaking changes are probably not going to be noticed by 99% of the people in the world. It's
Unless you're on a Mac.
yeah.
But-
Well, I mean, I'm
but
talking
it's
about
the It's
Go
the
ahead.
new API for 5.0, so is it client compatible? Otherwise, you will notice it. I mean, we notice it between Podman 3 and 4 because there is a new API, so it's not API compatible. But
this is the API is pretty much the same. There's just certain fields that are going to change because of compatibility with Docker. So yeah,
okay, so
you might have programs that might break because they're looking for a lowercase ID versus an uppercase ID being returned in the JSON file. Or,
but it will not outright break the way it did with the 3 and 4, so it will just refuse a connection. There is no such thing.
I would think it would not.
Yeah, that's something we might have a hard-coded check for API version in there, but I think we can probably relax that. We're not doing massive breaking changes between 4 and 5. Like, there are going to be small things. Podman stats might be broken in the sense that we've changed some of the JSON. It might not decode properly, but most commands, most API endpoints is still identical.
And
I
no
think-
real big changes to the network. We could have Paul speak on that, but there's been some subtle things done, but not like when we came out with 4 and said, "Oh, here's Netavark," and so forth.
We are hoping to default to pasta for rootless containers as opposed to the current slurp for NetNS default, but that hasn't got in yet. I'm actually going to be working on that this afternoon. So
Alrighty, it sounds like we're wrapping up, and I thought we'd wrap up the meeting as well pretty quick here. Are there any other questions for Matt about this or about anything else from today? Okay.
So if you want to test this new Podman 5, how would you, like, do you have a plan to get it to in the hands of Ubuntu users or Debian users or what have you?
nope.
So
We're not going to release binaries for the distros. Is that what you're asking?
no, it's just we had a discussion whether it would be like worse to have the Linux users use Podman machine compared to having them run Podman v3. So I mean, which is the worst scenario, running v3 in 2024 or running Podman? Because it was triggered by there was this nice blog post on how you can use Podman to run your Wasm binaries, and it was like Rio is Mac and Windows users. Now you can use Wasm binaries, but a lot of the Linux users were not able to follow that article because their Podman version was older than what was required in the article.
So this
So it was
is
just
mainly Ubuntu users, right? On older distros that never update their Podman.
Yeah,
So the idea would be to install Podman remote.
yeah,
Basically have a pile Podman remote statically, and then they could use that to launch a machine.
yeah, because that actually works as like a plan B. So obviously, it would be nicer to have them run the Podman v4. But so one thing I was experimenting just this weekend was to build Podman v4 using Podman v3. I thought that was quite interesting, and I have it running on Debian, Bullseye, and so on. So it seems to be working. I will put it up. So that could be one way instead of the Nix builds, because those were hard to maintain. So this one is not actually static, it's just building. They did the same for nerdctl, which requires new containerd that are not available in any distro. So they just put all of the binaries in a tarball and hope for the best. Same you can do for Podman if your distro version is outdated and you don't want to build it yourself from source.
Okay. Just need to wrap up here, Andrews. Can we have you contact Brent and or Matt?
Yeah, sure. But I think we would can follow up on coming meetings. 5.0 will be a while. So
Okay, sounds great. Are there any other questions that people want to bring up or topics for next time? We do have a couple of topics already for next time. Having somebody come in to show us how to deploy LLMs with Podman and Kubernetes. And we have Podman manifest support for artifacts, and Podman desktop is going to be doing a demo. So if anybody has any other thoughts, please let me know or add them to the agenda as we move along, as it's out after this. And one last chance for questions before we close out. Right, I'm not hearing anything, so thank everybody, especially the presenters today, and I'm going to stop the recording.